So the question I chose is the seirpinski triangle. I'm not exactly sure how to say that, but we'll go with that. So for A, we're asked to find the total area of the removed triangles after stages 1 and 2. So this is stage 1, and this is stage 2. And then it gives us the formula for area, where L, we're going to say in this case equals 1. And then in this case, L equals a half, and then in this case, L is going to equal a quarter. So we see that for the first stage, we've got one triangle removed, and the length of that triangle, the side length, is a half. So we're going to have one triangle times root 3 over 4 times a half squared. And that's going to give us root 3 over 16. For the second stage, we've got the first triangle plus 3 more triangles of side length a quarter. So we're going to have T1 plus 3 times root 3 over 4 times a quarter squared. And that's going to give us 7 times root 3 over 64. So now we're asked to find a general solution for Tn. So I'm going to create a chart here. We're going to call our stage number n. So if the stage is 0, that would be this stage. If the stage is 1, that would be this stage, 2, this stage. That would be 0, 1, 2, 3, dot, dot, dot. And then we're going to have our number of triangles removed. And I'm going to call this R for removed. So in the first stage we have 0 triangles removed, in the second stage we have 1 triangle removed, in the third stage we have 3 triangles removed, added on to the 1. And the third stage we've got 9 triangles removed. Dot, dot, dot. And then in the last column I'm going to go and say the length of the side length of the triangles that are being removed per stage. So in the first stage we don't have any triangles removed, so this length is not applicable. In the first stage, our length is a half. In the second stage, we've got that our length is a quarter. In the third stage, we've got our length is 1 over 8. And then we continue. So now we're going to come up with general formulas for each of these sections, so with respect to n. So for the number removed, we see that when n equals 0, r equals 0. When n equals 1, r equals 1. And each one is a multiple of 3 after that. So I'm thinking that for the number of triangles removed, I'm going to use 3 to the n minus 1. And this satisfies all these values given the value of n. And for L, I'm going to use 1 over 2 to the exponent n. So this works. So when we want to figure out what the total area removed is, we're going to need the number removed multiplied by the area formula, which is going to be root 3 over 4 times length squared. We're looking at a sum because we're adding on each term onto the original term, because each of these is with respect to the new triangle length. And because we have no value of L for n equals 0, we're going to have to start this series at n equals 1. So this is the sum that I've come up with, and I'm just going to simplify it a little bit. So further simplification gets us to this geometric series right here, in the form AR to the exponent n in this case, where A equals root 3 over 16 and R equals 3 over 4. And we know that for geometric series, if R is less than 1, when we take the limit as n goes to infinity of R to the exponent n, we get 0. So when we look at this sum, the general value for a geometric series is Sn equals A times 1 minus r to the n over 1 minus r. Then if we take the limit as n goes to infinity of the series, in particular this series is going to look like root 3 over 16 times 1 minus 3 over 4 to the n over 1 minus 3 over 4. And then we can say that this part goes to 0, so we're going to get root 3 over 16 times 1 over 4. And that's going to give us root 3 over 4. So that answers the last question, which asks us what's the area of the original triangle that remains as n goes to infinity. When we calculate the area of the original triangle, we get root 3 over 4 L squared, and L equals 1, the side length of the original triangle. So it's just going to be root 3 over 4. And then when we take into account that as n goes to infinity, we're actually removing this total area of 3 over 4, we get that an area of 0 remains.